Hi, in this video I'll explain about the basics of what is meant by an error in measurement. In measurement we take a number of readings and those readings are all slightly different from each other depending upon the equipment and the temperature and humidity on the particular day and so on. So if we have 10 readings for the weight of a pen and the weighing machine is very accurate, still we might see some variations in various readings. So we have to fix what is the variation or what is the error in this measurement. There are two parameters to measure that. One is the average and other is the standard deviation. Now look at the 10 readings on the top. If they are just 10 readings for a single pen, ideally that would be called the sample average. But if these 10 readings represent all the pens of that same make and size, then we can call it the population average if we do the sum of all these values and divide by 10. The difference between population and sample average is very important to understand. Now let's assume that it's the population average that we're talking about here, and the minimum reading given in that list was 0.021, the maximum reading was 0.029. The difference between these two does give an idea about the spread of the readings, which is 0.008. It's called the range. But is that the best measure of variation? The answer is no. Standard deviation is a much more robust measure of the variation because many values in between could be close to the average or far away from the average. Therefore, we need standard deviation. Standard deviation is a more robust method of measuring variation in readings because it takes into account each and every value and how much that changes with respect to the overall average. The easy way to remember standard deviation is to think of the word RMS. You'll come across this many times in physics: RMS current, RMS voltage, and so on. RMS stands for root of the mean of the squares. Now below you can see that expansion. The sigma is root of something, that is root of the mean of something, that is the root of the mean of squares, and the squares is talked about in the next slide. We square the differences of each reading with respect to the population average. Why do we do that? Because it's likely that some readings will be below the average, some will be above the average. So those which are below the average will show a negative difference of, let's say, x1 minus mu could be negative, x2 minus mu could be negative. We don't want all that. So we want to square them so that we'll get only positive numbers. And we add the positive numbers and we divide it by n, we'll get the mean. And we take a square root of the whole thing, so we'll land up with the RMS, or the root of the mean of the squares of the differences of each value with respect to its average. Now if there are 20 readings, it would take a long while to write x1 minus mu whole squared, x2 minus mu whole squared till x20 minus mu whole squared. So we need a shortcut, and the shortcut is to express all the x's as xi. So x1, x2, x3 is just I is equal to 1, 2, 3 and so on. So with this shortcut, sigma becomes equal to RMS once again. Root of the mean is 1 by n. Sum of the squares is I is equal to 1 to n sigma xi minus mu whole squared. Let's calculate the standard deviation for the 10 readings that we had. So inside the root we take the mean, that's 1 by 10, and inside the brackets we do x1 minus mu whole squared plus x2 minus mu whole squared right up to x10 minus mu whole squared. With that we will get the value of sigma as 0.00238 for the entire population. Now let's imagine that the 10 readings that we have are only representative of one pen and not for the full population. Then we cannot use the symbols mu and sigma. We have to use the symbols for a small sample of readings that we have taken, which is x bar for average and small s for standard deviation. Also inside these squares it will no longer be x1 minus mu whole squared, it will be x1 minus x bar whole squared. With all that, the equation looks the way it is, except that in the denominator it's not the mean 1 by n, but it's 1 by n minus 1, and that makes a big difference. The importance of n minus 1 in the denominator is that the entire value inside that square root becomes bigger. And as it becomes bigger, the standard deviation s also becomes bigger. It means that the variation is bigger in a small sample. If we take the readings on 10,000 pens, the population standard deviation sigma will be much lower. Now let's take a common sense example. If you ask 10 people, you will get a particular opinion. if you ask 10,000 people and do a bigger survey, you'll get a more robust opinion. That's the importance of surveys, and that's the real life application of average and standard deviation for you. Thanks and have a great day.